everybody. It's my first attempt at a vodcast, I think you call it. Um, my idea was to try and make one of these maybe every week or twice a week to help with the work we're going to be doing over the time we're not going to be in school. Um, it's my first attempt, so it's going to be quite amateurish, but I hope that you can understand me, and I'm sure I'll get better as I go along and try and improve this. So I thought I'd pick something that we've uh, not really spoken about yet. Just a small little topic that I could cover in maybe the next 5 to 10 minutes, and then I'll also be uploading some kind of worksheet to go along with this. But I've not written that yet. I'd like your feedback on this as well. So the thing I've chosen to do for today is something called the carbon cycle. It's part of section or topic 2.3, which we almost finished, but we didn't quite finish. It will also be on the Cognitive Classroom if you want to go there and look at that as well, especially if you don't think I've explained this very well. Okay, so what I thought was that I'm going to base everything we do on these little topics on syllabus. This is what the syllabus says about the carbon cycle. It's split into two sections: knowledge and understanding, and then applications. So, in order to understand the carbon cycle, the syllabus says that you need to understand matter goes through ecosystems, and that's what the carbon cycle is. Obviously, it's not a movement of energy; it's a movement of matter. Remember what we talked about when we talked about open systems. Cycles are basically connections of systems, and because they're connections of systems, they contain storages and flows, which systems contain. The storages in the carbon cycle are living things, which we call the organic, and the inorganic, which are non-living things, which include the atmosphere, the soil, fossil fuels, and water, especially the oceans. Flows in the carbon cycle include things feeding on each other, death and decomposition, photosynthesis and respiration, things like carbon dioxide dissolving in water, and then we've got combustion and fossilization. Fossilization includes the formation of fossil fuels, which we'll talk about. And the applications, well, the syllabus says you need to analyse quantitatively, so I'll try and find some questions based on numbers, and we need to also discuss the human impact on the carbon cycle. There's a very strong link to topic 7, which is global warming and climate change. So if you start by looking at the thing that's above my head, up there, I've listed the kind of things we're going to be talking about. So in the middle, for no real reason, because it's a cycle, it doesn't have a start or an end point, I've put carbon dioxide. Up here we've got methane. This is a fossil fuel. On this side we've got organic molecules that we find in living things. This is glucose, which is a carbohydrate. This is an amino acid, which makes up proteins. And this is a triglyceride that makes up fats or lipids. On the other side, this is a representation of coal. This is the molecular structure of coal. And then over here as well, we've got very simple structures like calcium carbonate, which is produced by mineralization. Now, what it doesn't say on here is there's two types of movements, we could call it, of things through the cycle. One is, we looked at these before actually with systems. One is a transformation. All of these things are transformations because you're taking an initial structure and you're turning it into a different structure. What I've not shown on this graphic up here is the other thing, which is transfers. Transfers would be maybe if you take glucose and the glucose moves from a plant directly into an animal by feeding process. That would just be a transfer process. So although it doesn't say there, I think it really should. It should also say that cycles can include two types of movements of molecules. One is a transfer and one is a transformation. Most of the things we look at here are transformations, I suppose. Okay, here's the carbon cycle. It's a fairly simplistic cycle in a lot of ways. We'll look at some more complicated cycles later, especially the nitrogen cycle. Now I decided to start with carbon dioxide Remember I said that a cycle has no beginning or end. We could start anywhere on the cycle, but I'll start with carbon dioxide. Um, I don't like the way they've done this, but they've included also in this box down here dissolving. Dissolving of carbon dioxide in water is a transformation process. When carbon dioxide dissolves in water, it turns into something called carbonic acid. It doesn't stay as carbon dioxide, dissolved carbon dioxide. Carbonic acid, as you might expect, is an acid, and one of the big problems of global warming that we'll look at later is that uh, one of the problems of humans putting more carbon dioxide into the atmosphere is that we're making the oceans, especially the Pacific Ocean, the biggest ocean in the world, we're making them more acidic. That's called ocean acidification. Okay, so we start with carbon dioxide. One thing that can happen is that the carbon dioxide moves into plants. So it goes from here to here. That's a process of transformation. And the transformation process involved is photosynthesis. We talked about that before. Okay. Plants, as do all living things, also respire. And the plants respire the glucose that they make in photosynthesis, and they respire it back into carbon dioxide. So there's a two-way process there. Okay, so that's autotrophic nutrition. Once the carbon is inside the autotrophs, it can get into the heterotrophs by the process of feeding. And here we see it going into a cow. The cow and the plants can die, and the carbon dioxide is then acted on by decomposers, and it turns back into carbon dioxide. If it's fossilized, it can turn into fossil fuels over here. As it decays, the carbon dioxide is released back into the atmosphere. So we come back to this starting point. Once the organic material is in fossil fuels, there's only one way you get it out of fossil fuels. It's by the process of humans combusting that material and sending it back into carbon dioxide in the atmosphere again. When you combust something, you join it with oxygen in the atmosphere. You join the carbon in the material into oxygen from the atmosphere, and you turn it back into carbon dioxide. That's basically the whole of the carbon cycle. I'll leave it there for a second. A few other things I thought were interesting as we talked about this. Although we talk about the big problem of carbon dioxide in the atmosphere, you should realise that carbon dioxide is only a very small part of the atmosphere. It's actually less than 1%, a lot less than 1%. It's probably about 0.04%. Most of the atmosphere is made up of nitrogen, and that will be important when we talk about the nitrogen cycle. 78% nitrogen, about 20% oxygen. So carbon dioxide actually does makes up a very small part of the atmosphere. You should also be aware that there are things called sinks of carbon dioxide. So a sink is a place of carbon. A sink of carbon is where the carbon ends up. The two main sinks on planet Earth. One is the living things. Now, trees or forests and grass make up a huge sink of carbon, and the other place is down here in the oceans. The ocean is the biggest sink of carbon in the world. Okay, I think that's all we need to cover with the carbon cycle. It's fairly simplistic. So just to recap, if I go back to the syllabus, we've talked about matter flowing through the ecosystem. In this case, the matter is the carbon atoms. I talked a little bit about storages and flows. The flows are the movement from one part of the cycle to another, and flows can be either transformation or transfer. Storages, I just mentioned sinks of carbon. Those sinks include the atmosphere, the oceans, and living things. Pretty much what it says there. These are the different types of flows here, and we also should include combustion of fossil fuels. That's a way for carbon to get from fossilization back into the atmosphere. One thing I didn't mention was mineralization. Mineralization is basically when carbon becomes trapped in rock. So it's this process. This is the process of carbon dioxide becoming, in this case, calcium carbonate, which is limestone. That could be through the formation of shells of animals. So Basically, animals that lived millions of years ago took in carbon dioxide. They made it into their shells. They died. The calcium carbonate that was in the shells sank, and it becomes mineralized rock. Okay, and then in terms of applications, I mentioned some impacts of humans have made, especially through the burning of fossil fuels. Um, I'll put a bit more information into that into the worksheets that are going to accompany this little video. Okay, and also in applications, I'll put this into a worksheet. I'll try and come up with some numbers. So when I set you work on this, I'm going to try and base it as much as possible on past paper questions. So I'm going to spend the rest of my evening looking through some past papers to try and come up with a workable worksheet to go with this. Okay, I hope you could follow it. I'll put this up maybe onto the blog, onto Google Classroom, a few places. Give me some feedback as long as it's not too nasty. Tell me how I can improve on this. Tell me if you can understand what I'm saying. And then after a few days, I'll move on to the next section, which I think is going to be the nitrogen cycle. Maybe I can make a better attempt at that than this. Okay. Thanks then. Keep working hard. Hopefully we'll see each other in a few weeks' time. I've got a feeling it's going to be about a month. And I'll keep trying to come up with these ideas for these little podcasts. Okay. Bye-bye.